Alrighty guys, so here's the AP Stat need to knows. So the first question was is to know the resistant and non-resistant measures of center and spread. Sketch a skew left distribution. So a skew left distribution looks a little bit like this, alright, where on the left side you have more of the lower values, okay, and as you move more and more to the right, that's where most of the concentration of values or data points are, okay. So what is the relationship between the mean and median for skewed left? So for skewed left, your mean will always be less than your median, okay? The reason that is that your mean is pulled towards the lower values, all right, of your data set, okay? And essentially will be smaller than your median, okay? So which measures of center and spread should be used? Well, for center, the best representation will be your median. That's in regard to a skewed left distribution, all right? So the reason why the median is the best representation, okay, is because it is less affected by any extreme values, okay? So again, if we have any extreme values, the middle won't essentially be changed. So if we remove a value from the left and the right, the middle will probably stay constant, okay? So for spread, the best representation will be your IQR, okay? Because your IQR evaluates your Q3 minus your Q1, which is 75% of your data minus 25% of your data. So that means that you're looking at the 50% of your data, okay? And that's normally not influenced by outliers, okay? So that means that it's the best representation, okay? So next we need to do is that we need to evaluate how operations affect the mean and standard deviation of a data set. Well, one thing you need to know is that when it comes down to standard deviation, that's normally the only thing that will be affected when you're mixing two separate data sets, okay? Your mean will normally stay constant. You normally can commingle two separate means, but for standard deviation, you cannot, okay? So the first question says, what is the mean and standard deviation of 4a minus 10? Right here, we're only looking at set A, okay? So that means that we can calculate this by just plugging in the numbers, okay? So I would have 4 parentheses, the mean for set A is 12 minus 10. 4 times 12 is 48. 48 minus 10 is 38, okay? So for standard deviation, I plug in the value for standard deviation for set A, which is 8. 4 times 8 is 32. 32 minus 10 is 22. Okay, so here it says what is the mean and standard deviation of set B? Well, set B, we're only looking at that one set, so that means I can just plug the numbers in. So I have 2 parentheses, the mean for set B, which is 20. 2 times 20 is 40. And then 2 times the standard deviation for set B, which is 6. 2 times 6 is 12. All right. Here it says what is the mean and standard deviation of A minus B, assuming independence. Here we are commingling two separate sets or two different sets with each other, all right? And because we're assuming independence, that means that our standard deviation will be calculated differently. Your mean will be calculated the same, so I would do the the mean for A, which is 12, minus the mean for B, which is 20. That will give me -8, all right? However, for standard deviation, we have to utilize our Pythagorean theorem, okay? So when you're utilizing Pythagorean theorem, what you're doing is that you're doing the standard deviation for A squared plus the standard deviation for B squared, okay? So the standard deviation for A was 8, and if we have that squared, okay, standard deviation for B was 6, and we're going to have that squared, okay? So 8 squared is 64, 6 squared is 36, okay? 64 plus 36 is 100, and the square root of 100 is 10, okay? So again, that would be the difference. So again, whether you're subtracting or adding, you have to utilize the Pythagorean theorem, because again, when you're trying to find any difference or any sum in between two separate standard deviations, you have to utilize your Pythagorean theorem, okay? So the next question. So the next question says we need to use the the linear regression equation to describe the residual given the data points. So the mini table output below is the LSRL analysis. LSRL means least squared regression line, to predict the grade on a test based on their study time. So because it said we're using it based on your study time, the study time is what's going to influence our data or influence our response. So that means it's your explanatory variable. All right. So our study time in what units? Minutes will represent our explanatory variable. All right. So what's going to be your response? Well, your response is what's going to be impacted when you do indeed study. So what will be impacted? Yup, your test grade or your grade on test. Okay. It didn't tell us in percentages or in points. Okay. So I don't have a unit to represent it as. Okay. So next it says, what is the equation of the LSRL given the stat output? All right, so your LSRL is your predicted value for Y, and you need to look at your coefficients to evaluate what that slope and Y-intercept is. So we would say Y hat, which represents the predicted value for Y. We need to now identify the slope. So again, this equation is going to look like Y equal mx plus b, because it's linear, all right? And the general form for linear is mx plus b. So m stands for your slope. So that's what we're going to try to identify, what number is going to represent my slope. So your slope impacts your x value. And we're saying that our x value is our explanatory. That's our x value. This is the y value. So your study time is essentially what's going to be impacted by your slope. Okay, so in this case, your study time in minutes is impacted by the coefficient of 0.8. So that would be your slope. And your y-intercept would be the 25. Okay, so what this is saying, if you wanted you to interpret it, it would be that for every 1 minute of study time, you'll be getting 0.8 of points. That's what we're saying right here. Okay. And what we're saying right here with the 25 is that if we did not study any time at all, we will at least get 25 points or percent or 25 for that test grade. Okay? So, but again, the question didn't want you to interpret it. It just wanted you to write the equation. So next it says identify and interpret. This time we need to interpret the residual for a student that studies for 1 hour and earns 80. Well, this 80 is what they actually scored, their actual score. So we need to try to figure out what the residuals would be between their actual score and what their predicted score is. Well, to find your predicted score, I need to use my LSRL equation. So I would say y hat is equal to 0.8. So the x that I'm going to plug in would be my study time. And it says that we're evaluating for a student that studies for 1 hour. But what's the problem with that 1 hour? Well, the study time is being represented in minutes. So I need to convert this 1 hour to minutes, and we know that 1 hour is 60 minutes, okay? So I'll replace here the x with 60 plus 25. 0.8 multiplied by 60 is 48. 48 plus 25 is 73, okay? So that's what we are predicting they should get, okay? So based on their prediction and based on what they actually get, we actually under-predicted because we predicted a lower score than what they actually get. So how much did we under-predict by? Well, to figure out how much you under-predicted by, you do your actual score minus your predicted score. So I would do 80 minus 73, which is 7. So that means I under-predicted by 7 points or percent. They didn't tell us what units. So this is what we're going to say, okay? So when we're interpreting it, we're going to say based on our LSRL analysis, the model tends, I like those specific words, to under-predict, okay? So it tends to under-predict by 7. It didn't tell us points or percent, so I'm just going to say by 7 for test grade based on 60 minutes of study time. All right. So that is how you interpret it. We didn't have much space to try to do it all on one area. So try to use up your space wisely. Okay. So the next question wants us to identify types of test and experimental design vocabulary. So we need to describe the meaning of response bias. So response bias just means that somebody is essentially not being honest whenever they're giving you some type of response based on the methodology that you're using. Okay, so we could say that based on methodology used, individuals were dishonest in their response. Okay? So again, guys, for example, if somebody already, I'm gonna use the mermaids example, okay? So if somebody already watched a bunch of mermaid movies, they watch Finding Nemo, they've watched a lot of things involving the sea. If you ask them if they loved mermaids or at least had an interest in mermaids, they would automatically respond a little bit more positively to wanting to be involved in mermaids because of the fact that they already were exposed to mermaid content, whether via TV, books, and so forth. All right, so they already had some type of bias towards it. Okay. So the next one wants us to compare the type of claims that can be made from observational studies versus controlled experiments. All right. So for observational, what you can deduce from it, all right, is correlation. All right. So again, whenever you're looking at observation, you're looking at how things are correlated to each other. Correlated or correlation. Okay. When you're using a controlled experiment, okay, that's more causation because you're keeping something constant and you're trying to evaluate the effect that something has on it. Okay. Give an example of blocking in an experiment. An example could be, for example, blocking by, so say you had a set of students in a school, all right, and you want to evaluate what group comes late most frequently. You could do blocking based on school grade, okay? So I would evaluate based on students who were freshmen, sophomore, junior, and senior, all right? If I separate my school into those different areas, I can evaluate how many freshmen were frequently late, sophomores, juniors, seniors, and then identify what group is frequently or more late than everybody else, okay? But you can block by anything. You can block by age, by gender. You can block by any type of quantifier that you want to identify your experiment for, okay? So the next question. So the next question wants us to use mathematical models for probability associated with a binomial scenario. So a binomial scenario is like yes or no, ones and zeros, ups and downs, all right? So essentially things that have an equal probability, all right? So for example, a flip of a coin, all right, so forth, okay? So it says the probability that a certain NBA player makes a three-point shot is 0.4. Assuming independence, calculate the probability that the NBA player will make exactly 3 of 5 three-point attempts in the game, okay? So in this case, when we're trying to find what the probability that NBA player will make exactly 3 of 5, we need to take into consideration that if they're making 3, they're also missing 2 because they're shooting it 5 times. So when I'm evaluating this, I would do the probability of making it is 0.4 to the third power because we're trying to make it 3 times. So now we need to evaluate the probability that they don't make the shot. So the probability that they don't make the shot would be minus the probability, 1 minus the probability that they make it, which would be 0.6. So they will make it, or they won't make it, probability will be 0.6, and they won't make it 2 times, all right? So the probability of making it 3 times and then multiplied by the probability that they don't make it twice, okay? And then we need to now consider the amount of ways we can make it. For example, we can make the first shot, but and then make the second, third, and fourth, and miss the last one. Or we can miss the first 2. There's many ways that you can represent this. To represent the amount of ways, you can do a choose function. You can do 5, choose 3, because we have 5 attempts, all right, and we're trying to get 3 of them, all right? So we can plot something like this directly in your calculator, all right? So again, to get your choose, this is what you do. You press alpha, you press the Y, okay? You go to the right, and then you go to N, choose R. N represents the number of trials, all right? R is the ratio that you're trying to evaluate it for. In this case, 3 shots that we need to make, or the success I need to make is 3, okay? So the number of trials is 5, and the success I need to make is 3, okay? So 5 choose 3 is 10. So now I need to multiply that by 0.6 squared and 0.4 cubed, okay? So I would do my answer multiplied by 0.6, or let's do 0.4 cubed, all right, multiplied by 0.6 squared, okay? So when I did that, I got 0.230, so 0.2304, okay? So that's the probability that they make 3 of 5. So what's the probability that the NBA player takes 5 3-point attempts in a game, they make more than half? So more than half means if they shot it 5 times, half of 5 is 2.5, but you can't make 0.5 of a shot, so they need to make either 3, 4, or 5 shots. So what I'm going to do is that I'm not going to do this entire calculation for each of them because this is going to be time consuming. I'm going to use a calculator function to help me to do this. The calculator function you can use is binom PDF, okay? But because we're doing it for 3, 4, and 5, okay, because again, we're trying to make more than half, we're going to do the binom PDF for each of those areas and add them together. So when you're doing binom PDF, you need to remember the perimeters. So to get binom PDF, you do second function vars, and then you can go up and you go to binom PDF. So you need to take into consideration your trials, your probability, in this case, of success, okay, and the X value you're evaluating it for, okay? So in this case, the amount of trials that we're shooting it 5 times, okay, we're evaluating the chances that they make it, so the probability that they make it is 0.4, okay? And then we're trying to evaluate it for 3, 4, and 5, because we need to make more than half. So we're going to do it for 3 first, okay? So I input all the same things in, 5.4 and 3. And when I calculate that, I got this result. And what I'm going to do, I'm going to do the same thing for 4, 5, all right? Just so I can get all of those out of the way. So what I'm going to do is I'm going to go up, press enter, and change this 3 to a 4. Go up again, press enter, and change that 4 to a 5. And those are all my values, okay? So again, you would do it for 3, 4, all right, and 5, okay? So I don't have enough space to write all of these. I'm trying to squeeze it. Okay, I'm trying to squeeze the next one right down here. Okay, so you do for each of them. Okay, so 3, 4, and 5. Okay, so what we're going to do is that we're going to add up all these values together. I don't have enough space to add them up to write each of them out, but I'm going to add them all up together. So 0.1024 plus 0.0768 plus 0.2304. And I got 0. So the answer to this would be 0. Because again, you're adding all of these together. 31744. Okay, so that's the result. All right, guys. So the next question says, what's the probability that the first made 3-point attempt, all right, comes from the third attempt? So that means that we're shooting it 1, 2, 3, 4, 5 times. But if we're the first time we are making it is the third time, this will be the only one that has a probability of success. So our probability of success will be 0.4, and we're trying to make it where the first time we make success is that third time. So that means we need to miss it the first 2 times. So what's the probability of missing it? 0.6, okay? So if I want to find out the probability that we make it on the third time, all I got to do is multiply these to each other. I don't care about when I make it any other time afterwards, or if I miss it, I just need to take into consideration I make it the third time. So when I multiply all these together, I would do 0.4 times 0.6 times 0.6, and I get 0.144. Okay? So that's the probability that I make it on the third attempt. Okay? So the next question. So the next question wants us to calculate the utilize the TI-84 and 1 VAR statistics and apply the 1.5 IQR rule. Okay, so the 1.5 IQR rule helps you to find your lower and upper fence, which are boundaries in which you can evaluate if you have any outliers. Okay, so it says calculate the boundaries for outliers and identify and classify any outlier. Okay, so what you're going to do is, in this case, you won't write out all the calculator functions like TI-84, list 1, this, that, and third. Just identify your Q3, your Q1, your IQR, 1.5 times your IQR. All right, so those are the things you're going to try to evaluate. Okay, but the first thing we need to do is that we need to input all these values in our stem and leaf plot into a list. Okay, so I'm going to pause the video and put all of these into a list, and then I'll give you what those values are. So when I inputted those values, my Q3 was 46, my Q1 was 17.5. In this case, I was not able to identify our I think I might have put in my list wrong. I'm not sure. Okay, because I think I might have put in my list wrong. Okay, so when I did my 1 VAR statistic, okay, oh no, this is actually all I need. I'm sorry, guys. This is all I need, okay? So, for my IQR, guys, I would do Q3 minus Q1. So, I would do 46 minus 17.5, okay? And 46 minus 17.5 is 28.5, okay? So 1.5 times my IQR would be just 1.5 times 28.5, okay? So my answer times 1.5 would be 42.75, okay? So now we need to identify our lower and upper fence, okay? Your lower fence can be calculated by doing Q1 minus 1.5 of your IQR. And think about it, it actually makes sense because Q1 is 25% of your data set, and if I'm trying to look lower than that, I have to subtract, okay? So that's why we're subtracting for Q1, okay? So when I do that, I would do 17.5 minus, or 1.5 times IQR is 42.75, so 17.5 minus 42.75 will give me negative 25.25. That would be my lower fence, okay? But in this case, was there any numbers that was lower than negative 25.25? Well, we didn't even have any negative numbers, all right? So that means that there was no outliers as we move towards the left, okay? So now we need to do the upper fence. To do the upper fence, we're evaluating Q3 plus 1.5 times your IQR. And that also needs to make sense because Q3 is 75% of your data set, and if you're looking to the right of it, you're trying to add that IQR, okay? So I would do 46 plus the 42.75, and then I would get 46 plus 42 would be 88.75, okay? And that would be my upper fence, okay? But in this case, guys, was there any numbers that were bigger than 88? No. Our biggest number was 80. So based on our lower and our upper fence, we have no outliers. Okay? So again, guys, we would have no outliers. All right? So the next question. So the next question wants us to understand normal distribution and apply the z-score formula. All right? So what is the z-score formula? So the z-score formula is that z is equal to your x value that you're evaluating it for minus your mean divided by your standard deviation. Okay? So again, because it said utilize your z-score formula. Okay? So it says the height of an adult woman is in a particular population follow a normal distribution. So a normal distribution means that I have some normal curve, all right? So some type of bell curve, okay? So the researchers have collected data on the height of random sample of 1,000 adult women, okay? And found out that the mean height was 64. So the mean will be the center for a normal distribution. So this would be 64, okay? And then the standard deviation was 3 inches. So this is 64 for the mean, all right? And the standard deviation was 3, okay? So what is the z-score that corresponds with 5 feet tall, okay? So the main problem right here, guys, is that it's representing 5 feet. But what units were we given this in? In inches. So we need to convert this 5 feet to inches. So a foot is 12 inches. So I just need to multiply 5 times 12, okay? So 5 times 12 is 60, okay? So we need to evaluate for 60 inches, all right? So in this case, we need to use our z-score formula. So we're going to say that z is equal to the x value I'm trying to evaluate it for, which is 60, minus the mean of this data, and the mean was 64. All right, and then divided by my standard deviation, and my standard deviation is 3. Okay, 60 minus 64 is negative 4 over 3, which would be negative 1.33. So you can leave it as a fraction or the decimal. Okay, so the next question was the probability of a woman between 60 and 70 in height. All right. So in this case, guys, because we're looking at a perimeter in between certain areas, we need to use the calculator function normal CDF, okay? So, normal PDF, because we're doing probability. I apologize, okay? So when we're doing this, we need to take into consideration some things, all right, which are your lower bound, your upper bound, your mean, and then your standard deviation, okay? So in this case, guys, all right, I would have my lower bound being 60, okay, because I'm looking in between 60 and 70. So that means my upper bound is 70, my mean is 64, and my standard deviation is 3. So I will go ahead and go to my calculator, and I'll type that same thing in. So I press second function vars, go to normal PDF, hold on, maybe I was wrong. Oh, sorry guys, it's CDF. So I was correct before. So it's not PDF, it's CDF. All right, apologies guys. All right, so we're using normal CDF. So when we look at that lower bound, the lower bound is 60, upper bound is 70, the mean is 64, standard deviation is 3. Okay, so we got 0.886, all right, and that would be the result. Okay, so then the last question, what is the female height that's associated with the top 10%? So if we're looking at our normal distribution and we're evaluating for the top 10%, all right, we're evaluating this area right here. So we would say that this is the top 10%, okay? But to evaluate the top 10%, I need to take into consideration the bottom 90%, okay? So I'm evaluating all for the bottom 90% to evaluate what the top 10% is associated with. So in this case, guys, I will need to use inverse norm, okay? Because I'm trying to find the height that's associated with it, okay? So the area that I'm going to evaluate it for, so when you're doing inverse norm, okay, you need to find an area evaluating it for. So I'm actually looking at this area right here, that 90%. So 90% is the same as 0.9, okay? So that's the area that I'm evaluating it for, 0.9. The mean would be the same mean that we had, okay, which is 64. Standard deviation is 3, okay? So 64, standard deviation 3, okay? And then when we paste that, the height that's associated will be 67.84 inches, okay? So there we go. So the next question. So the next question wants to evaluate our and R squared and interpret the correlation coefficient and correlation of determination. So you should remember that your correlation coefficient is your R, your determination is your R squared. Okay? So it says, refer to the context to the LSRL problem to the left. So this problem to the left. Alright? If R squared is 0.6, then what is the value of R? So in this case, we don't need to use this equation or this table to help us. If we want to know if we know R squared and we want to know R, all I gotta do is take the square root of R squared. So the square root of R squared is the square root of 0.6. The square root of 0.6 is 0.777. All right. So 0.77 actually 46. Okay. So that's our R value. How do you know if R is positive or negative? Well, to figure out if R is positive or negative, we need to use our LSRL equation, okay? And this is what you need to know, all right? If your slope is positive, your coefficient or correlation coefficient will also be positive. Okay? Because again, your slope tells you direction, alright? And if our function is moving upwards, okay, and our data points should follow our general linear regression line, if it's going upwards and being positive, that means the R also has to be positive. Okay? So the next question, it says interpret the Pearson's correlation coefficient. So we need to interpret the R. So the R was 0.7746. So the R, which is the correlation coefficient, was 0.7746. Okay? In this case, guys, when you're trying to evaluate what it is, you need to take into consideration if it's a strong, moderate, or weak correlation, all right? And then we need to also take into consideration if it's a positive correlation, all right? So those are the things we need to understand or try to answer, okay? So in this case, guys, I would state that this has I would say it would have a strong positive, okay? So a strong, we already know it's positive, okay? Correlation. Okay, we can also say linear too. So linear correlation or relationship. All right. So you could also maybe say between study time, that's you, and test grade. All right, because it wants us to take into consideration the information to the left. All right. So again, guys, that would be the best way of interpreting it. Okay. So interpret the coefficient of determination. So the coefficient of determination is your R squared. So our R squared was 0.6. All right. So that 0.6 can be represented as a percent. So this is what we would say. We would say that 60% of variation in test grade, okay, can be explained by the linear relationship. Okay, and you can also state what the relationship is between, okay, so the relationship between test grade, study time and test grade, between study time and test grade. All right, Bob. Okay, so now let's try the next question. So the next question says we need to apply basic probability formulas, all right, and find out given A, probability of A is 0.4, probability of B is 0.25, what is the probability of A union B if A and B are independent events, okay? So the probability of A union B is actually represented as a formula. So this is the same as saying A or B, okay? So the probability of OR, okay, is the probability of A plus the probability of B minus the probability of A and B. Okay? So we were given that the probability of A was 0.4, probability of B was 0.25, but we weren't given the probability of A and B. Well, what you should remember, guys, is that the probability of A and B can be actually broken down as this. The probability of A and B is the same as probability of A multiplied by probability of B. Okay? So in this case, the probability of A multiplied by B would be 0.4 multiplied by 0.25. Okay? So I put all this in my calculator. Alright? So when I put all this in my calculator, I just type it as such. Okay? So 0.4 plus 0.25 minus 0.4 times 0.25. Bam. Alright, so 0.55. Alright, so that's the probability of A or B given that they're independent. So it says, what's the probability of A or B if A and B are mutually exclusive? Well, mutually exclusive is telling you that one thing, alright, is exclusive of the other, alright? They don't have an impact on each other, alright? Or sorry, they will have an impact on each other, alright? So that's what I think. Yes, guys. So I was correct. So mutually exclusive does mean that you have two or more events that are happening at the exact same time, alright? So they are not essentially going to be independent of each other. Alright, so because of that, guys, we need to know that for something that's mutually exclusive, you cannot evaluate the probability of A and B. Alright, this value will always be 0. So when I'm using my formula here, probability of A or B is equal to probability of A plus probability of B minus the probability of A and B. I'm essentially just trying to find the probability of A plus B, okay, for mutually exclusive. So this is actually the only thing I'm trying to find. So I'm doing 0.4 plus 0.25 because, again, here we'll be subtracting what? 0. So we can kind of just eliminate that. So 0.4 plus 0.25 is 0.65, okay? So next question. What's the probability, or rather, if the probability of A and B is equal to 0.5 or 0.15, then what's the probability of A slash B? This slash in the middle means given, okay? So you need to remember the given formula. So the formula for given, okay, so A given B will be the probability of A and B divided by the probability of the second scenario B, okay? So we were given that A and B is 0.15, probability of B was 0.25, so I'm going to now just divide those, okay? So 0.15 divided by 0.25, I got 0.6. Okay, so I got 0.6. Okay, so the last question, guys. So the last question, it gives us, or rather, it wants us to explore discrete random variables and the tree diagram. So a large sample of people is taken and asks how many homes they have. The summary data is below. So 0 homes with this probability, 1 home with this, 2 home, 3 home, and 4 homes. What's the mean and standard deviation number of homes? Okay, so what I need to do, guys, is that I need to try to make a list for each of these, where this will be my list 1 or my X values, and then this will actually be my list 2, which is actually going to represent your frequency. Alright, because the probability that something happens is the frequency that it happens. Alright, so I'll go ahead and make a list. Okay, so I'm just quickly make that list. 0, 1, 2, 3, 4 for 0.45, 0.1, or 0.35. You have to make sure that they all match. 0.1, and then 0.07, then 0.03. Okay, so you have to make sure that in your list they all match up with each other. Okay, so then I press stat, one var statistic, and then put your frequency list as your list 2. Okay. Bam, okay, so in this case, our mean, okay, or X bar is 0.88, okay, and our standard deviation, which we're going to use this to represent the standard deviation, is 1.0419, okay. So now it says 2 people were selected at random. What's the probability that they each had at least 2 houses owned, okay? So in this case, guys, when I'm trying to figure out though at least 2 houses owned, I'm figuring out 2 or more, because the smallest I can have is 2. So I would need to add up the probability of 2, 3, and 4 houses. So I would add 0.1 plus 0.07 plus 0.03, okay? And that would give me 0.20. However, this would be the probability if we had only one person selecting, all right? But in this case, we have 2 people. So in case of 2 people, we need to now square it. So this will now be 0.04. So this is the probability for 2 people who selected to have at least 2 or more houses, okay? So at least 2 would be 2 or more, okay? So the last question, it says 2 people were selected at random. What's the probability that at least one of them owned a home? So if I'm saying at least one of them owned a home, I'm saying the only thing that I can't take into consideration is persons not having a home. So I need to do 1 minus the probability of not having a home or no home. All right? So no home. So what was the probability of having no home? Probability of having no home was 0.45. Okay? However, we're looking at the probability that when we selected that person, we're selecting 2 people we're selecting. All right? So I need to do the probability of no home for 2 people selecting. So I need to do this value squared. So I need to do this value squared. Okay? So when I put on my calculator, okay, 1 minus 0.45 squared, okay, I get 0.7975. Okay? So again, guys, just like that. If you had just done 1 minus 0.45 and then square that answer, okay, you'll get a different result. And this would not be the same as what you're saying here. Because what you would be saying there is that you'll be doing the probability of them having at least 1 and then squaring it afterwards. But we need to do it first. So we need to do the probability of having no home, because that's when we're doing that essential probability change. Okay, and then after that, that's when you do it 1 minus it. Okay, so again, guys, just like that.